Okay, good afternoon, ladies and gentlemen. First of all, I would like to thank you for watching and continuing to watch and subscribe and um, bring me more subscribers. First off, I'd like to wish everyone a happy Independence Day, happy 4th of July. Hope you guys are being safe out there. Don't drink too much, don't party too hard. Most of you guys have to be at work tomorrow, so. But enjoy, nonetheless, enjoy your day and remember what the true meaning of 4th of July represents. Not so much the barbecues and the cookouts and stuff like that, but just take a second out to remember our fallen soldiers and the sacrifice that they have made. At any rate, again, welcome you guys back to Meteorology for Professional Pilots. We last left off at air masses in their source regions, kind of like the source regions: continental Arctic, continental polar, continental tropic, and maritime polar and maritime tropic. And as we can see, they're on both sides of the contiguous United States. And remember that the source region, these source regions are like the birth certificate of air masses. Now, we also talked a little bit about how, even though these air masses originate at their source regions, they come into contact with land, and whatever properties that the land has, like, as far as water regions or dry regions and stuff like that, the air masses change characteristics. So they're born, and it's kind of like becoming an adult. You leave your home where you may have customs and courtesies and things that you do, and then as you go older, you come into contact with different information in different environments, and you kind of change your perceptions as you come into contact with the new environment, and you change your perceptions and the way you think about things. So what I have here is a summary of air mass features, and this is concerning the source region. So just to jump back in, continental Arctic. On this side of the diagram, we have temperature, level of moisture, and stability. You can look at this part, but at this point in time, I really don't want you to be concerned with this. This is the tropopause height, and I guess just to think about it, you can just think of, it gives you the height of where it lies in relation to the tropopause. For instance, this very cold, dense air, the continental Arctic. So as a result, it is going to be very dense, and we know if the air is dense, it's probably going to be very low to the surface of the earth and not so close to the tropopause. So I hope that makes sense. So continental Arctic, I've installed this picture in here, and we have very bitterly cold and dry air. So the temperature of an air mass starting out in the continental Arctic source region is going to be very cold. Level of moisture is going to be dry, and it's going to be very stable throughout, which means it's going to resist up and down currents or vertical movement. Our next is maritime Arctic. It's going to be cold, moist, and it's going to be unstable at the lower levels as far as the stability of the air mass. And it's going to be low as well. It's not going to stretch, that air mass is not going to stretch very high up into the troposphere. Our next player is continental polar. We talked about this being in the region of Canada. have cold temperature, moisture levels, moisture, I'm getting tongue-tied again, the level of moisture is going to be dry, and the atmosphere is going to be very stable throughout, still lying very low in the troposphere. It's not going to extend that high. Maritime Polar. Temperature is going to be cool. Level of moisture, it's going to be moist air, and stability is going to be unstable. And it will climb a little bit higher into the troposphere. Our next player is Maritime Tropical. It's going to be hot, moist, very unstable, and it's going to reach into the higher levels of the troposphere. Now notice, when we talk about our hurricanes or tropical storms, where do they come from? When you see the weatherman saying, oh, we got Hurricane Sandy or Tropical Storm blah blah blah, Jim, or whatever, typically the tropical storms and hurricanes and tornadoes, they don't get male names, they get female names, strangely. But here's the United States, here's Florida down here, here's Southern California going into Mexico. This is where these tropical storms pretty much generate. Just pay attention, because we're coming up into, we're in July, in August, and when we get this tropical storm development, these hurricanes and things of that nature, you're going to find that they all come from here typically. I think more so here, this area, and we'll get into why. But the source region that creates that environment is very high temperature, lots of moisture, and the air masses in that area that start out here, they really don't resist instability, so they're very unstable, and they reach very high into the troposphere. And Continental Tropic, over Central America, Mexico, those regions, very hot, dry. As far as level of moisture, not a lot of moisture, but there is still some instability there, so it's still very unstable, and they reach very high into the troposphere. So these guys reach really high into the troposphere. These guys not so much, very low, and then this guy's super low. The air masses hug towards the surface of the earth. Here they get a little bit higher, they don't hug as much, and here they stretch very high into the troposphere. So those are our source regions. The degree, now we're going to talk about modification a little bit. We have our source region, and we just talked about the characteristics of our source regions. All right. Here we talk about our temperature and level of moisture. But as the air masses, let's say air mass 1, the source region was continental polar, so very cool and dry. But as air mass 1 gets down into here in this area, Montana, Nebraska, that's Nebraska, North, South Dakota, what's going to happen is it's still pretty much it should maintain the same uniform. But over in this area, the Great Lakes area, it could pick up a lot of moisture coming from the continental polar region. It can pick up moisture, and then it can change. So that's what we mean by air mass modification. Another thing that it depends on is the speed. How fast? If it doesn't hang over the Great Lakes very long, it's not going to pick up a lot of moisture. If it's moving slow over the Great Lakes, it has the ability to pick up a lot of moisture. So the modification, or the air mass's ability to change, depends on the speed that it moves over, like the water areas. Conversely here, if air mass 2 is coming in, and we talked about this is like the area, because I don't want to mislabel it, Maritime Tropic, very warm and moist air. As it comes in, if it comes in very, very fast, it'll probably lose a lot of its moisture. If it comes in very, very slow, it may not lose a whole lot of moisture. It'll do it at a slower rate because it's just given that, how should I say, it's just given, if it moves slow, it's holding on to a lot of moisture, so I would tend to think it's probably not going to lose it as fast as opposed to air mass 2 just coming in really, really fast. Well, it'll come over to land, and it won't have a lot of moisture in that area, not a lot of large open bodies of water, something like up here at the Great Lakes, so it probably won't pick up a lot of moisture. So these are just things that we need to keep in mind as we buzz around the sky. So what did I add here? And the temperature difference between a new surface. Okay, so it depends on the speed and the temperature difference. If the continental polar air mass is cool and dry, when it gets over here into the warmer regions, down into say like Oklahoma, Kansas, Missouri, and all that stuff like that, all right, these are warmer surfaces, so they're gonna like warm it up. It's gonna raise the temperature, and then it won't be continental polar anymore. It'll be, instead of cold, it'll be warmer. So modify means to change. So the air mass is being modified by the speed at which it moves over into the new area, and the temperature of that new area all plays a part. Here we can see air coming in, and it can have warmer. You can have a warmer surface here, a cooler surface here, and as we raise the temperature via like evaporation, we can add moisture to the air mass, and then when it gets over here, over the colder region, then what happens is dew point. The air mass, or that body of air, the temperature drops, and the moisture that it picked up here through evaporation comes out in the form of precipitation or fog. So, something to think about. So, here's some ways we can change or modify air masses. We could warm it from below via that previous slide, where the evaporation is coming up, adding heat. We could cool it from below. Air mass moves over a body of water, and it just changes. It drops. The temperature drops. We can add water vapor, as we saw on the slide, or the air mass changes by subtraction of water vapor. When we subtract the water vapor, what do we get? Precipitation. The condensation nuclei, they say, hey, we're just way too heavy, man. We got to fall. We're out of here. So, you can just pause at these points, and you can go into the different reasons why. But everything kind of comes back to stability. The stability of an air mass determines its typical weather characteristics. Alright, so as we saw in our previous slide, the source region kind of helps determine how much stability this air mass is going to have. And we talked about how the air mass can be modified, it can be changed as a result of the speed and the temperature of the land or water that it moves over. Just looking at my talking points, when one type of air mass overlies another, the conditions change with height. So this warm air mass, and this is a warm front, by the way, and we're going to get into this, but as height increases here, let's just say we took off here, and we just go straight up, like our space shuttle example. We go up, 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 up. We have a cold air mass, and then we transition into the warmer air mass, and the conditions change. So we can get different weather type situations. Just to be clear, on stable air or stable air mass, we're going to get, back to our clouds, stratiform clouds. We're going to get smooth air, and we're going to get fair to poor visibility. If we do get precipitation out of that stable air, it's going to be continuous. It's going to be a steady rain. It's not going to be all windy and just blowing around and, you know, what do you see? Like in really nasty windy days, you see stuff blowing down the street and all that and everything. The winds and the rains are just whipping and just doing all kinds of crazy stuff. So continuous precipitation in that stable air situation. In our unstable air mass situation, we'll get cumuliform clouds, turbulent air, and strangely, good visibility. And that is actually a Federal Aviation Administration weather test question for pilots. And this is going to lead us into our front and stuff. And I just want to make sure I didn't jump too far ahead. I did. What I wanted to do was touch on. Let me just see. Okay, let me just stable air. I did want to talk about front. So, a zone between two different air masses. Because if we come back to our slides, make sure I don't go too far off target. Now, we have situations where we have air mass 1 and we have air mass 2. Now, both of these, just think of these people as two children when they were in their source region. They were born and they grew up, they got older, they traveled the world, like these air masses are doing. They're traveling the world. And they have different perceptions, thoughts, and things like that, or characteristics, as opposed to the experiences that they've been through, i.e., the land that they passed over, and the temperature of the land that they passed over, and the speed at which life happened for them. All right, I'm just trying to give you guys some things, some memory aids that you can trigger. You can use to trigger thought. So then these two air masses come into contact with each other. Well, at first, they don't know each other, so there's going to be a boundary between these two air masses, and we're going to talk about those boundaries. Back to our slide. So the boundary between these air masses would be called a front. Okay. So, or frontal zone, a frontal zone. All right, so the zone between two different air masses is a front or frontal zone. Across this zone, temperature, humidity, and wind change rapidly over a short distance. So if I'm flying from the left side of this graphic to the right side of this graphic, I'm in the warm air mass, and I'm flying. When I cross this front or this boundary between two different air masses, then wow, it went from 62 or 55 to 31 degrees. That is a serious drop, or a noticeable drop. All right, so when you pass through the front, we're going to get a change. All right, and it's going to be very abrupt, typically. Let's see. You can read that on your own. You can pause and read that on your own. But temperature is the most easily recognized discontinuities across the front. Like I just mentioned, we fly from here to here, or from here to here, at 62 degrees to 31 degrees. In a situation where if you're on the ground and this front passes over, you're going to feel a drop in temperature. You're going to be like, wow, man, it was 62. I didn't need a windbreaker. Now it's 32 degrees. Damn near free. Well, actually below freezing. That's 32. Water freezes at 32 degrees Fahrenheit. So if we go from 62 degrees Fahrenheit to 31 degrees Fahrenheit, that is a serious drop. And people are going to be like super cold and freezing. An abrupt change. So here's some changes. You can pause here for a second and read on your own. It's plain English. Dew point. That also changes. You can pause and read that on your own. Winds change. Pressure changes. Atmospheric pressure. And then what we'll do is we'll go into types of fronts. All right. So we identified air masses. We'll either have a cold air mass taking over a warmer air mass, or a warmer air mass taking over a cooler air mass, or we'll have something where two air masses run into each other. So what we're going to do is we're going to talk about the air masses. We're going to show you what they look like, what's going on in a meteorological sense, and how they look on the chart, because we're going to have to delve into looking at these weather charts and stuff. And for you kids out there that are interested in weather, when you see a warm front or cold front or stationary front, these are the first two I'd like to deal with. We're going to look at some other ones down the road, but these are the first two that I want you to start thinking about in your building block process. The cold front. The cold front is a situation where the leading edge of an advancing cold air mass overtakes a warmer one. All right, so we see our cold air, we see the direction of movement, and we see what the warm air is doing. It's kind of like, wow, this cold air mass is pushing us around. Let's get out of Dodge. Here, we can see the symbol for the cold front. All right, they'll be in blue, and you see triangles, and the triangles will be pointing in the direction that the front is moving. So, just based on the fact that we see this symbol, we know that it's a cold front. We know that a cold air mass is overtaking a warmer air mass. And just by looking at it on a chart or like on a weatherman screen, or I should say weather person, because they're not all men. Just by looking at that, we should be able to visualize what's going on. Colder air, the leading edge of this cold air mass is pushing out the warmer air. So when we look at that, this is what we should see visually when we look at this. Here we're looking at it from a satellite view or a bird's eye view. This is commonly where you would see the cold air mass, all right, or the cold front. We know that when we look at A, we know that there's a cold air mass pushing in this direction because of the triangles, and we know that the warm air mass is being pushed away. Here we have a similar situation. At B, we have a cold air mass here, and we should know that there is warmer air here being pushed out of the way. So when our weather personnel or weather personalities talk about, oh, we got a cold front coming in from the northwest into Washington State and Oregon, or for our East Coast people, well, probably a day prior to this cold air mass was over here and the cold front was over here, and what the weather personality predicted was that the cold front was going to push out the warmer air into the ocean. So here, cold air mass, here, warmer air mass. And it doesn't necessarily have to be cold, just colder. So even in the summertime, we can have cold and warm air masses. But this is just to indicate a cooler versus a warmer air mass. Let's see. And actually, this is from 2 days ago. It's the 4th of July now. This is from July 2nd, 2016. So that is my point exactly. It wasn't freezing cold at all. Well, 2 days ago, I was walking outside in a t-shirt. I walked to this restaurant I frequent that's close by, and I was in a shirt and t-shirt. I was in a shirt and t-shirt. I was in shorts and a t-shirt. So it was not cold. It was just cooler than the present warmer air. I had all my talking points. The warm front. The warm front is a situation where warmer air replaces cooler air. Okay, the edge of an advancing warm air mass is a warm front. Warmer air is overtaking and replacing colder air. So this is what it looks like graphically on a chart or on your weather personalities screen. You'll have semicirculars or half circles, and it's in red. Here, if we're flying across, we notice a noticeable drop. Did I? Anyways, I'll just back up. I digress. Sorry about that. So we fly from here, 55, and then bang, we have a drop, almost 30-degree drop. Same here, 62 to 31 degrees Fahrenheit. That's what tripped me up. I had this in the previous slide. That's all. So here's our warm front. All right, the warm air is replacing cooler air, and when we see this, this is what we need to visualize. Warm air is pushing, cold air is being moved out of the way. All right, here we have a warm front. Warmer air is replacing cooler air. Again, this is from July 2nd. So here is where we have our warm front. And here we have something called a stationary front that we're going to get into next. That's how we want you to visualize. So we talked about the warm front, the cold front, the warm front, and then we have the stationary front. In the stationary front, we got two people, it's like a war. We have the cold front on this side, we have the warm front on this side. And we got different moisture contents on both sides. So in this case, neither air mass is replacing the other. The front is stationary. This is how it looks like as a graphic. You can see the warm air on this side, the cooler air on this side. And the depiction is always going to be warm air. The depiction is going to be on the opposite side of the line. The cooler air is on this side, but it's just to indicate the direction that the air mass is trying to push. So these bulbs on this side means, hey, there's warm air on the other side fighting. These guys are like the messenger, the representative. Hey, warm air is coming. This representative says, these representatives say, hey, cold air is coming. But neither one replaces the other one. And as a result, it just kind of hangs out there. Here, as I mentioned, cooler air is on this side, warmer air is on this side. And it's a stationary front. They're just kind of hanging out. Nothing's moving either way, whereas as opposed to here, warmer air is overtaking cooler air. And this side, where we talked about our cold front, cooler air is replacing warmer air. So just some things that I want you to be initially aware of. We have our cold front, we have our warm front, and we have our stationary front. Now there are more that we're going to get into. There are, there's a bunch of other symbols that you could see on that weather chart. But our cold front, warm front, and stationary front is what I want you to be concerned about. You can go on your own. You can pause at this point, go on your own, and you can research the other ones if you want to, but we are going to cover them. All right. We already know about the high and the low pressure areas. We did that, and we covered that in another video. highs, lows. Here we have, when we have a low with a TD, this is called a tropical depression. We'll talk about that. Tropical storm has a hole in it. A hurricane does not. So you can go back to eating your barbecue, drinking your beer, hopefully not too much beer. Thank you for watching Kieno Training Systems. I'm Kieno Thomas. Happy 4th of July. Thanks for watching. Please like, share, and subscribe. Talk to you later.